Okay. We're doing solving equations, and I like solving equations. Not as much as verifying identities or proving identities, but it's still fine. It's like feels very algebra-ish. Anyways, throughout the lesson, we're going to need our double angle formulas. Like you'll see, we'll use them a lot. In theory, we could use half angle as well, but I don't see any half angle problems on this. But anyways, our double angle formulas for sine, we got sine 2 theta equals 2 sine theta times cosine theta. And then for cosine, you got cosine 2 theta is equal to cosine squared theta minus sine squared theta. Cosine actually has 3 of them, so we can get it all into cosine. If I were to change this to 1 minus cosine squared, it would turn into 2 cosine squared theta minus 1. In a similar fashion, you can change the cosine into sine, and you would get the statement 1 minus 2 sine squared theta. I think that makes sense. Yeah, because it's 1 minus. Yep, perfect. So this is like the 3 versions of the double angle of cosine, and then we have our sine double angle. We're going to use them. Going to use them a lot, I think. Anyways, let's take a look at the first set of problems. Number 1 seems pretty easy. 2 sine theta plus 1 is equal to 0. We're solving for theta. I don't know what's going on there. I'm going to subtract 1 from both sides, so I get 2 sine theta is equal to negative 1. I'll divide by 2. I get sine theta is equal to negative 1/2. So for what values of theta is sine theta equal to negative 1/2 on the interval from 0 to 360, as they're asking. So this is going to be a 30-degree angle. So it's like all our 30-degree angles. But the sine is negative, and sine's negative in the 3rd and 4th quadrant. Remember, sines are y values. So it's this 30-degree angle and this 30-degree angle. So this angle would be 210, and this angle would be 300. Oops, 330 maybe. Yeah, so our answers are 210 and 330. On to the next problem. Number 3. See, like we already have a double angle. So cosine 2 theta plus cosine theta is equal to 0. There's nothing we could do this problem written like this, so we have to use one of our double angle formulas, and I'm hoping that this makes sense, but I basically want to get everything in the same trig function. So I don't want like a sine and a cosine floating around together. It's really hard to solve. I either want to go all cosine or all sine. So we're going to use the second, this guy here, the second double angle formula for cosine. So this will turn into 2 cosine theta minus 1 plus cosine theta is equal to 0. 2 cosine squared theta. 2 cosine squared theta. I'm going to like move everything around. 2 cosine squared theta. I'll get a plus cosine theta and a minus 1. This is a quadratic form. There's a 2nd degree term, a 1st degree term, and then, a constant. If this is too weird for you, do use substitution, let u equal cosine, but this will factor, or hopefully it'll factor. If it factors, it'll factor in a product of binomials. So how do I make 2 cosine squared theta? Well, I could have 2 cosine theta and a cosine theta. That'll give me my 2 cosine squared theta. And then how do I make factors of 1? Well, there's only one way to make factors of 1 and 1. And then I have to fool around to make sure to get the correct sign. Well, 1 has to be positive, 1 has to be negative. And you fool around enough, you'll see that this one has to be negative and this one's positive. And you can foil that out and verify it. I really do just kind of guess and check. I don't use like an AC method or tiger method or dragon method. I just guess and check. I was taught guessing and checking. I teach guessing and checking. It's not that bad. All right. Anyway, so we have the 0 product property, which says I can take each factor set equal to 0. I'm going to go ahead and do that and solve at the same time. So I get cosine theta is equal to 1/2, and I get cosine theta is equal to negative 1. So we got to solve both of these guys. Excuse me. So when is cosine theta equal to 1/2? Well, on the unit circle, it's going to be like my 60-degree angle, and cosine is positive in the first and fourth quadrant. So this would be 60 as well. So we have theta equal to 60. In the first quadrant will be 1/2. And in the fourth quadrant, which would be 300, would also be 1/2. When we solve this, cosine theta is equal to -1 when theta is equal to 180 degrees. That's not bad. 3 answers. On to the next problem. I'm going to go a little thicker on the to zoomed out or something. Okay, I like that. I am on 5. I don't understand 5. 5. Cosine theta is equal to -rad3/2. Well, it's already solved. So we're just figure out what theta is. Again, on the unit circle, cosine is going to be negative on these 2 quadrants. The -rad3/2 is going to be at a 30-degree reference angle. So this would be 150 degrees, and this would be 210. So theta is equal to 150 degrees, 50 and 210. No big deal. On to the next problem. That was interesting. You didn't actually do any work. All right, 7. We have cosine 2 theta is equal to 8 minus 15 sine theta. Again, you're going to do that like, I need to get everything in terms of sine. It's really hard to get sine. It's really hard to get sine in terms of cosine, but it's easy to get cosine 2 theta in terms of sine. We can go back up to our lovely double angle formulas, and this third one would work really well for us. So I'm going to go ahead and say cosine 2 theta is equal to 1 minus 2 sine squared theta, and this is equal to 8 minus 15 times sine theta. And now everything's in terms of sine, and then it like turns into a quadratic. We're going to factor. It becomes very similar. I'm going to move everything to the right-hand side so that the leading coefficient is positive. So I get 0 is equal to 2 sine squared theta minus 15 sine theta. Does this even factor? I don't know. 7. I think it's going to factor. This will be a plus 7. So I'm going to subtract over 1 and I'll get a plus 7. Assuming this factors, I think it does. This would be 2 sine theta. This would be sine theta. If you notice, I need to have a 14. So the 7 needs to go here. They're both going to be negative. And that's what we have. So I'm going to continue here. When I solve, now I have a like factors, like a product. Factors equal to 0. I set each factor equal to 0. When I have a product that is equal to 0, I set each factor equal to 0. So I get sine theta is equal to 1/2, and sine theta is equal to 7. So when is sine theta equal to 1/2? This is going to be the first and second quadrant, and it's going to be a 30-degree angle. So it's going to be theta is equal to 30 degrees, and theta is equal to 150 degrees. What about this guy? Well, the largest that sine can be, and it should make sense because sine by definition is like the opposite over hypotenuse, and the hypotenuse is always greater than or equal to the opposite side. So the biggest that sine can be is 1 because the hypotenuse is always longer, if that makes sense. So this will never happen. We can toss that out. Anyways, our answers are right here. Boom. On to the next problem. I'm on 9. Okay. I got it. Do I got it? Yes. Here's 9. 9. I got 4 sine squared theta minus 1 is equal to 0. I guess I'm going to solve this by factoring. Maybe it's difference of 2 squares. 2 sine theta plus 1. I think I could have just solved like and used square roots as well. I think we would get the same answer. So I get sine theta is equal to 1/2, and I get sine theta is equal to negative 1/2. Anyways, when I do this, and I'm going to do this in that K form, and we want to do radian measures, sine is 1/2 at 30 degrees or pi over 6. And if we added two pi k to it like this, every time k is an integer, this would be true. So we basically add one entire circle, one entire circle, one entire circle, one entire circle, however many times we want. So this is one of our answers. Sine is also positive in the second quadrant, and that's 5 pi over 6 plus 2 pi k. This is another answer. What about sine theta is equal to negative 1/2? That's going to be in the third and fourth quadrant. So this would be, let's see, 5 pi over 6, 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k. Now we can simplify this somehow. Let's see. Let me draw a picture. Okay, so I believe this guy, and this guy have the same reference angle, and they're a pi apart. So they're 180 degrees apart. So if I wanted to, I could say I can combine these two with this statement. Let's see, pi over 6 plus pi k. Like, go by pi instead of 2 pi, and then we'll get back to there, and we'll get back to there, and we'll get back to there type of thing. So that's one solution. It kind of basically takes these solutions and combine them as one. And the same thing with this guy. I could do like 5 pi over 6 plus pi k, and the same argument. It would basically, they're a pi apart. So I don't know. I personally don't care what the answer is. It's just, I don't know, it's just a little bit cleaner. Let's see what the textbook has. I don't even know. Oh, I don't know. I don't like their answer, but either one's going to work. All right, on to the next. Plus or minus. I got it. I don't like that. I don't like what they did. It seems lazy. I like this one better. Or this one. I'm thinking. Now I'm over it. All right. Let's do 11. All right, 11. We got cosine. All right, we're taking a pass on 11. It turns into like a third degree polynomial, and then you have to do the rational root test, and like, it doesn't make sense. Like, it doesn't make sense that you had like really easy ones, and all of a sudden it just jumps into rational root. I'm going to say this is like a typo or misplacement of a problem. Right now, it's not appropriate. Maybe later, but right now we're gonna skip 11. Maybe have your teacher do it in class. See if they can do it. All right, I'm jumping over the 13. Cosine 2 theta plus 4 cosine theta. Oops. Cosine theta is equal to -3. This will turn into we're going to do the cosine one. So this is 2 cosine squared theta minus 1 plus 4 cosine theta is equal to -3. I'm going to set everything equal to 0, or set it equal to 0. 2 cosine theta plus 4 cosine theta. I believe this will turn into a 2, a positive 2, if I did that correctly, equals 0. Let's see if I'm doing this right. I feel like just dividing everything by 2 onto both sides, like, why bother with bigger numbers? So cosine squared theta plus 2 cosine theta plus 1 is equal to 0. Factor this bad boy out. So you get cosine theta plus 1 plus 1. I believe that does work. You'll get the 2 cosine theta in the middle. Set this equal to 0. When is cosine theta cosine theta equal to -1. That's when theta is equal to pi. When does that happen again? Well, it happened at 2 pi, 3 pi, 4 pi, 6 pi. Actually, careful. We need -1. So it'll be pi, and then it'll be 3 pi, and then 5 pi. But basically, this has the relationship of pi plus 2 pi k. Or 2k pi? I don't know what I like better. But basically, take pi and multiply by some multiple of, or add to some multiple of 2 pi, and you'll get all the answers. All right, on to the next. We are on 15. Now it says do the same thing, but do it in degree measures, but these are very similar. 15 is cosine 2 theta minus sine squared theta plus 2 is equal to 0. I guess same thing. Cosine 2 theta, this can be written as 1 minus 2 sine squared theta. Minus sine squared theta plus 2 is equal to 0. Technically, I don't have to move everything to the right, but I think I'm going to. I don't know. I'm thinking. I don't know. Okay, so anyways, this is going to be 3 minus 3 sine squared theta is equal to 0. I guess I'll just solve this way. So I get sine squared theta is equal to, I'm going to subtract 3 and then divide by -3, and I'll get sine squared theta is equal to 1. So sine theta is equal to plus or minus 1. When is sine theta equal to 1 or plus or minus 1? This is problem number 15. Okay, I like their answer on that one. All right, so obviously sine theta equal to 1 is going to happen at 90 degrees plus 360 degrees times k. And sine theta equal to -1 as 270 degrees plus 360 degrees times k. That's how often it'll happen. But if you want, these are only 180 degrees apart. So if you want to get all of them, imagine, let me see if I can draw this on the circle. Like here's the first one, here's the second one, here's the third one, here's the fourth one. It's all 180 degrees apart. So this would be an equivalent answer of these two guys here. It'd be 90 plus 180k, which the book went with that one. I like it. Yep, looks good. 17 looks familiar to another one we did. I mean, it's really just cosine 2 theta. Yeah, I think I'm going to go that route. All right, so I'm going to go 2 sine squared theta, just kind of mix it up, is equal to 0. I think I could have done this on another problem. I don't remember seeing it. Equals 0, but this is really cosine 2 theta, so I'm going to say cosine 2 theta is equal to 0. And basically this answer is true. One's cosine 0 at 0, and at pi, and so on. So I'm going to say when 2 theta is equal to 0 plus, so again, it's going to be at 0, and it's going to be at pi, it's going to be at 2 pi. Wait, yeah, I lied, not 0. Cosine is going to be 0. Cosine is going to be 0 at pi over 2, or 90 degrees, and then 270, and then back another, so it's only differs by pi. So our answer is going to be 90 degrees plus 180 times k. I can have it as two separate ones, but I kind of like it condensed as one. And so what's theta equal to? Theta is equal to 45 degrees plus 90k if I divided both sides by 2. Again, we solved this for 2 theta, and then we're solving for theta just by dividing by 2. That's not bad. Hopefully that's logical. On to the next problem. 19, we can't do. Not that we can't do it, but it's the exact same problem as 11. Exactly the same. It's going to turn into a trinomial, or not trinomial, but a cubic, and then you have to do the rational root test, and then find one of the roots, and then do long division, and then it doesn't sound fun. All right, let's skip on 21. Wasn't fun. All right, jumping over to 23. Yeah, 23. Tangent squared theta plus 2 tangent theta plus 1 is equal to 0. Factor tangent theta plus 1 I believe it factors into that. So I get tangent theta is equal to -1 on the unit circle. That's going to happen there, and that's going to happen there. This is 45 degrees, and this is 45 degrees, or pi over 4. But if you notice, our answers are pi apart, if that makes sense. And we add another pi, and they're pi apart. So I'm going to say theta is equal to, not pi over 4. That doesn't make sense. Does it make sense? No, it doesn't make sense. We're going to be in the second quadrant, 3 pi over 4 plus pi k, or k pi. Yeah, that makes sense. No big deal. All right, on to 25. 25, we have sine 2 theta minus cosine theta is equal to 0. This doesn't look too bad. Use double angle for sine, so 2 sine theta times cosine of theta minus cosine of theta. You should see that that's factorable. I can take out a cosine theta, and I get 2 sine theta minus 1 is equal to 0. I set each factor equal to 0. Cosine theta is equal to 0. And I'll set sine theta equal to 1/2. When does this happen? This will happen at pi over 2 and 3 pi over 2, and so on. So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. You know, what do these differ by? They differ by pi. So we can do pi over 2 plus pi k, or k pi. As one of our answers. I'm just double checking. Yep, perfect. And then what is sine 1/2? Sine is 1/2 in the first quadrant, so that'll be pi over 6 plus 2k pi. Man, I'm very inconsistent with that. And that will also happen in the second quadrant, which is 5 pi over 6 plus 2 pi k. All right, I got a couple more here. Number 27, that looks challenging. Maybe. I don't know. 27. 27, I got cosine of 8 theta is equal to 1. This doesn't look too bad. So basically we can say whenever 8 theta is equal to 1 is cosine 1, cosine 1 is 0. Or whenever 8 theta is equal to 2 pi, 4 pi, so on and so on. So this is going to be 8 theta is equal to 0, 0 radians plus 2k pi, or 2 pi k. And then I can solve for theta, so I get theta is equal to 0 plus pi over 4k. Yeah, I think I like that, pi over 4k. Looks good. This is 27. I'm just checking my answer. Okay, I'll take it. That's not bad. It's not terrible. 29. Yep. 29, I got 2 cosine squared theta is equal to cosine theta. I don't know why they gave this to you, but it doesn't look too hard. Just set equal to 0. 2 cosine squared theta minus cosine theta is equal to 0. Factor out the cosine. Cosine theta is equal to 2 cosine theta minus 1 is equal to 0. I get cosine theta is equal to 0. And I get 2 cosine, oops, I'm going to solve this. Cosine theta is equal to 1/2, positive 1/2. On this guy, we've already talked about him. When is 0? That's going to be pi over 2 plus pi k. When is this guy 1/2? Well, this guy's going to be 1/2 in the first quadrant when theta is equal to pi over 3. And that'll be true every time we repeat. And it'll also happen in the fourth quadrant, which is 5 pi over 3 plus 2 pi k. Don't worry, I'll check my answers. I think we're good. Perfect. I am done, I think. Am I done? I hope so. Wow, that one looks hard. All right, thank you so much. Goodbye.